Assalamu alaikum. Our new chapter in grade 11 scientific is chapter 8 derivative. Let's start with part 1. Objectives. Calculate the number derivative at a point. Identify the number derivative as the slope of tangent. Determine equation of the tangent. And finally, identify the special cases where the tangent is parallel to x-axis or y-axis. Students, prepare your materials, textbook, pens, draft paper, copybook, and calculator. Revision. Slope of a straight line. The slope of a line is a specific term for the steepness of a line. Slope equals vertical change over horizontal change. Positive slope, straight line going uphill. Slope equals 0, straight line is horizontal parallel to x-axis. The slope of line D passing through points A and B is simply yb minus ya over xb minus xa. The positive slope means that when x increases, so does y. And when x decreases, y also decreases. Example. We want to calculate the slope of the following examples. The first remember that slope equal y difference of y over difference of x. In the first example, by calculation, the slope equal 1. In the second example, by calculation, the slope equal 4 over 0. In this case, the slope is undefined, so the line is parallel to y-axis. In the third example, the slope equal 0. So the line is parallel to x-axis. Back to our chapter. Number derivative of a function. Definition. We define the number derivative of function f at x0, f prime of x0, denoted by f prime x0, equal limit f of x minus f of x0 over x minus x0 as x tends to x0. This is a definition. Example. Find the number derivative of function f at x0 equal 1. F prime of 1 equal limit x tends to 1 f of x minus f of 1 over x minus 1. Do the calculation. Of course, you should remember to factorize and simplify. And we get the answer. Application. Calculate the number derivative at x equal minus 1 of the following function. Solution. Apply the rule f prime minus 1 equal limit f of x minus f of minus 1 over x minus minus 1 as x tends to minus 1. Applying the rule. Then do the calculations of limits, etc. We get the answer minus 1. Graphical interpretation. If you look here at this video, you notice that the 2 points are approaching each other in order to have a tangent at one point. We say the number derivative of function f at x equal x0 is the slope of the tangent to the curve at the tangency point. I mean, here, the tangent here at this point on the curve, the slope of this tangent is simply the number derivative at x0. Let's see an example. Consider function f represented by this red curve. We want to calculate the slope of the tangent at point A, here. The slope of this tangent at point A. Depending on the definition, the slope is the number derivative at xa. So the slope of this tangent is the number derivative at xa. at x equal minus 2. Apply the rule. Slope equal f prime minus 2 equal limit, etc. We do the calculations of the limits and we get the answer. To check up our answer, we can depend on the old method, which was 2 points on the tangent a and b, and we calculate yb minus ya xb minus xa, and of course we will get the same answer. Application. This red curve, and we have tangent at a. You should calculate the number derivative of function f at x equal minus 2, I mean at point a. Okay, here we don't have the explicit form of the function. Pay attention. Solution. Simply we select 2 points on the tangent a and b, and we say that the number derivative of function f at x equal minus 2 is the slope f prime minus 2 is the slope of the tangent, and we calculate the slope of the tangent yb minus ya over xb minus xa. So simply f prime minus 2 equal 4. I will repeat. We say that f prime here at x equal minus 2 equal the slope of this tangent, and we can calculate the slope of the tangent by doing the calculation yb minus ya over xb minus xa. So we get f prime of minus 2 equal the slope of the tangent. Now we'll talk about how to calculate the equation of the tangent. Simply we have the following rule. Y minus y of the tangency point equal f prime at x a, x minus x of a, the tangency point. Example. We have function f of x equal x squared. We have point a abscissa 3. We want to write the equation at point a. Equation of the tangent at point a. Y minus f of xa equal f prime xa, x minus xa. Simply, we apply the rule. We calculate f of xa alone, and we calculate f prime of xa alone, and we substitute, and as you see, we get the equation of the tangent. Application. The same steps. Do it by yourself. Solution. Apply the rule. Do the calculation f of xa and f prime of xa. Substitute. Continue. We get the equation of the tangent. Finally, we want to talk about the special cases when the tangent is parallel to x-axis or y-axis. The first rule. If the tangent is parallel to x-axis, the slope of the tangent is f prime of at x0 equals 0. This case. The second case, if the tangent is parallel to y-axis, then f prime x0 does not exist. This case. Okay? Two simple rules. Example. Calculate f prime 2 in this figure. To this point, the tangent, we notice that the tangent here is what? Is parallel to x-axis. So we say f prime 2 equals 0 since the tangent is parallel to x-axis. Simply. Application. The function f of x equals x squared, you should calculate f prime 0, then interpret your result graphically. Solution. F prime 0 equal limit x squared minus 0 squared over x minus 0. Apply the definition of the number derivative and we get the answer. It is 0. Then what we deduce? We deduce that the tangent is parallel to x-axis. Okay? Since the number derivative is 0. The slope of the tangent is 0. Summary. Definition of number derivative of function f at x0. This rule. Graphical interpretation, the number derivative is the slope of the tangent. Equation of the tangent, and finally, tangent parallel to x-axis. The assignment. Our homework is exercise 1. These are the parts. And exercise 15. And these are the details. Thank you, our dear students.